there's only when there's only two x-intercepts, there should be a one turning point on the x-axis. So in other words, one of the x-intercepts is a turning point. In this case, when x is -1, we have a turning point there. Okay. How do? Okay. The idea is when after we factorize the cubic equation, if we have a bracket and if we have a perfect square in the bracket in one of the after factorization, make whatever inside the bracket equals to 0, x equals to -1. So when x is -1, we have a turning point. Okay, you have to know that this when we have a perfect square, make whatever in the when we have a perfect square as a factor, make it equal to 0, and we will find the x value, and we will find the x coordinate of one of the turning point, and the turning point is always located on the x-axis. It is very simple. Okay, you have to remember this for your final exam. It makes your final exam much easier. Okay. Let's look at question D. In question D, yeah, okay, y is sorry, I just rewrite the question first. Y equals to minus x cubed plus 2 times x squared plus 2, and sorry, I missed one term. It's minus x cubed minus 2 times x squared minus x plus 2. Now we have to factorize it. The shape of the graph is this because of the minus sign, because of the minus coefficient of x cubed, and we use okay, and now we have to factorize it by try and error and long division. Okay, let's assume the factor is x plus 1. Let's say when the factor is x plus 1, we have to substitute x equals to -1 to find the remainder, which, okay, remember, well, we talked about it before. Make it equal to 0, x will be -1, and we substitute it into the function to find the remainder. Say if it equal to 0, so I will have minus 1 cube minus 2, well, plus 2 times -1 square minus 1 plus 2, and I will have -1 plus 2 plus 1 plus 2, which is not 0, so this is not a factor. And we try another factor. So let's try x minus 1 as a factor. So when we have to substitute x equals to 1 to find the remainder, and remainder will be -1 plus 2 minus 1 plus 2, again, which this is not. Again, this is not, well, it doesn't equal to 0. So let's try another factor. So x minus 1 is not a factor. Let's try another one. Okay. Let's say maybe I try x minus, yeah, sorry, just wait a minute. So let's try x minus 1. Sorry, let's try x minus 2. And we have to substitute x equals to 2 for the remainder, say if it is equal to 0. So the remainder will be minus 2 cube plus 2 times 2 square minus 2 plus 2, which is minus 8 plus 8 minus 2 plus 2, which is 0. So this is our factor, and we do a long division on that. Okay, and well, I just do it very quick because we explained how to do long divisions in detail in the previous video. So it's minus x squared okay, I have a 0 minus x and plus 2 minus x and divided by x will be minus 1, and yeah, the remainder is 0. Our factor is that, so y would equals to x minus 2 bracket times minus x squared minus 1, and we take the minus out from the second bracket. I will have x minus 2 times x squared plus 1. Okay, so let's find the x and y intercept. So when x equal to 0, y will be 2. So when y equal to 0, x will be, that's our y-intercept, x will be 2. Yeah, that's the only y-intercept we have, because well, because when 0 is minus x bracket x minus 2 times x squared plus 1, x can only be 2. Okay. Now let's sketch the graph. Our y-intercept is 2 and x-intercept is also 2. The graph looks like this, so I think we would have something like that. Okay. This is our x-intercept, which is 2. Y-intercept is also 2. Because there's only one x-intercept, so the graph looks like this. Also, it maybe looks like that, but okay. Okay, let's put it this way. Okay, so this should be a graph. Okay, because we don't have to find the exact coordinate of the turning point for now, but if we do a differential equation on that, try to find, and we can find the exact turning point, and we may be we can will able we able then we will be we will able to obtain a more accurate graph. But for the math you learning now, this graph is good. Well, it's good for this answer is acceptable. Okay. Um, yeah. Okay, just leave. Okay, but in your year 12 exam, you have to label the turning point. You will be. I will show you how to do it in the chapter of differential equations. Okay. Now let's look at the next examples.